So just a few more concepts with our sedimentary rocks. So sedimentary rocks can form in sedimentary basins. So a basin is basically something you could think about like a bowl, right? So it's going to catch a lot of materials. And a lot of times these basins form due to subsidence. So what's happening here is you've got your rock that's sitting at the bottom, and you've got a lot of sediment that's coming in on top. And that sediment that's coming in on top is very heavy. And what that sediment will do is it'll kind of push down on it. So it's like if you have a house that has a really old floor, and you put something heavy on that old floor, it's going to cause that floor to kind of warp a little bit. That's subsidence. Usually what we see here is that sinking of the land due to the weight of the sediment sitting on top. Now these basins can be really important because in these basins we can find lots of really important resources like coal, petroleum, gas, and uranium. So all important energy sources. So places where we can form sedimentary basins, the first is going to be a rift basin. So as our continent is getting pulled apart here, right, getting pulled apart into two pieces, remember the earth doesn't just crack open and leave a gaping hole all the way down to the core of the earth. As it cracks open, it's going to kind of crack from the top down. All right. So as it cracks from the top down, right, you're going to get this nice valley that's going to form. And of course, in that valley, right, of course, as divergence happens, it's going to get deeper and deeper. But in that valley, of course, you're going to get lots of sediment, right, lots of rivers and lakes that are going to develop in there, depositing lots of sediment. Along our passive margins, which remember here we don't have any subduction that's happening, we get material that's going to collect. So basically here we've got sediment that's running off of the continent and getting deposited. The weight of that's going to push down on it, right? So remember there's our slope, right? So we've got the weight of all that material kind of pushing it down, getting deposited there. We can also find these things called intracontinental basins, which are pretty cool. Most of these formed millions of years ago, back in the Paleozoic. So back in the Paleozoic, most of North America was covered by a huge ocean, actually all the way through the Mesozoic. And because of that water that was there and all the sediment that was getting deposited, again, that material was just really heavy, and it caused the continent to warp. And it formed these really big basins. Like here, I mean, you can see the Michigan Basin is literally the size of Michigan. The Illinois Basin is the size of Illinois. It's really impressive. So littered across North America with these huge basins. And what's pretty impressive is the material that we can find in there. In the Michigan Basin, we find lots of salt, tons of salt, which if you put two and two together, right, that's where you can find Morton salt. So it's definitely pretty important. We can also find basins in the foreland area. So the foreland area we find kind of at the base of our mountains. And I really like how this analogy, the author of the book has really made this analogy great. So mountains, remember, are very heavy. The crust is much thicker there, so it's pushing down on the crust. So it's kind of like a weight, you know, pushing this down. Because it's getting pushed down, you've got this downwarped area right here. So all that material that's going to erode off from the mountains is going to get collected right there. So all of this erosive material is going to get collected right here in that foreland basin. Now, it goes without saying that sea level changes over time, right? I just mentioned a few minutes ago that in the Paleozoic, North America was covered by a huge seaway. So sea level definitely changes. This is something we're worried about today. And we can map what sea level changes look like by the rocks that we find. So a transgression is what we call a sea level rise. Okay, so when glaciers melt, water gets bigger, right? It gets deeper. And it's going to push up onto the land. So as that water comes up onto the land, it's bringing those finer deep water sediments onto the continent. So what we're going to find is, right, if I'm standing on the continent, now it's deep water, I've got lots of these fine sediments getting deposited on top of me. So what we form here is called a fining upward sequence. So here down at the bottom, I might have been standing at the beach, right? Well, as the water gets deeper and deeper, if you remember back to what we talked about environments, we get the shallow marine getting deposited on top of me. So I've got some shale. If the water continues to get deeper, right, I might get limestone deposited on top. And these grain sizes decrease, right? It gets smaller and smaller. Remember, the deeper the water, the smaller the particle. So when I see these fining upward sequences in the rocks, that's telling me, right, that was due to a sea level rise. Now, we can also get a sea level fall, right? A sea level fall is due to when the climate gets really cold, glaciers get really big. And we're going to see the opposite, right? Where I might start out standing at the beach, now sea level moves out, right? And let me take that back. Let's start down here. So we're going to start down here at limestone. All right, we start out here at our coral reef. The water level drops. Pardon my mistake there. Water level drops, and now we're out there in the shale, right, at our shallow marine. Water is going to continue to drop, and we're going to get the beach. So what we can see here is the sediment size increases. Okay, so we call that a coarsening upward sequence. So we find that in the rock record, right, that's telling us that we have a sea level drop. So telling us about climate. Now, of course, there's many things that can happen to our rocks after they get deposited. That whole process we call diagenesis. Right? We can get bioturbation. Remember, that's little animals going in there and mixing everything up. Lithification, right, turning into rock. Dissolution, right, as groundwater works through it. Minerals getting precipitated. If it gets buried deep enough, right, it may experience metamorphism. So our sedimentary rocks can really end up going through a lot of stuff.